Good. Yeah, then welcome everybody to my talk. Thank you also to Piers. And of course, thanks to all of you that you're joining this talk. The title, as it already says, is Cypress and Database. And it also has a quite of a little bit strange subtitle, namely The Elephant in the Room. And I think it is the best if I just start with telling you a little bit about me, what I'm doing, so that you know how the idea of this talk actually came into being. So my name again, so I'm Rainer. What I'm doing, I'm a trainer and consultant actually, not for Cypress, but for Angular at Angular Architects. You will probably not know me, but if you're an Angular developer, then chances are quite high that you know Manfred Steyer. He's the head of Angular Architects. Yeah, and lately we also have added to our program a special workshop for testing, and in that workshop we are doing Cypress. So this is where the connections comes. And you know, there are always two kinds of developers when we are starting with the Cypress chapter. There is one group who sees Cypress for the very first time, and then there is another group who is already experienced a little bit with it. So the first group, how it usually works, I'm just showing them the basics of Cypress. This is actually done very short. Everybody gets it because Cypress is really easy to understand and easy to start with. And especially from the beginners, the first question is always, especially if they have a background in Selenium or something like this, does it really work like that? Is it really that easy? And I always say, yeah, it is really like that. You also don't have any flaky tests and so on. The second question, of course, is always about the build pipeline, what is required. Also very easy answer there. And then always comes the question, okay, but what should I do with the database? What is the right approach? Do I have to restart it all the time? Do I only have to restart it before I run the complete test suite? Or how am I going to do this? And the same question is also asked by the more advanced users. So they say, you don't need to show me Cypress. I know how it works, but I want to learn a little bit about some best practices, how I'm going to deal with this database thing. And this is where the idea was born, that I said, yeah, I want to give a talk where I want to summarize the patterns that we have developed so far. And of course, it would be nice if I also get some feedback after this presentation. Maybe there are some things you have to add as well. Yeah, let's see. To give you a little bit of a better understanding about these, the context or the problems, I have two specific examples. I mean, this is now not for part of the slides, so I'm just telling it you just like this. So just think of an end-to-end test where you have a list of customers, and inside of that list you want to test a certain feature, how this list would look like if there are no customers. Is the right information message shown? I hope that I don't get an error and so on. What I would have to do if I'm working against an existing database is that I would have to remove, of course, all my customers first. Then I can check if it works. But then the problem starts, because it can happen that afterwards another test is running against the same database, because for some reason I can't just reset the database all the time. And then this is a certain test that wants to edit the first customer that is shown in this list. So this test will probably not work. Another example is that, for example, we have end-to-end tests where we are dealing with logged in or signed in users. Most of the time it happens that our database is providing us with some kind of test user account that we can use. So we log in with this user and do whatever we want to test. And now it could happen that we add a new feature. Let's say we have some kind of a social login connection so that I can log in with my Google or Facebook account or whatever. And if I'm doing that, then again, I have the problem, because now the login process looks completely different. But it really depends which test run after this test, because if they want to try login in the old way, they will all fail. So this is the area of problems that we're facing with. And if we want to see this in a little bit of a more from a theoretical perspective, then it looks like this. So we have multiple tests. All these tests go against the same database, and it really and these tests, they change our databases. So what we have is that, first of all, the ordering is important, because test number 1 can do something that test number 2 is not aware of or might depend, as I just mentioned, and then it would fail. So what we are introducing here is something that we have actually a tight coupling, so or you can say dependencies between these tests. And this is very bad, because we know already from normal application development, I mean, as soon as everything depends on each other, we will not come very far in terms of code size. So we will very soon reach a step we will very soon come into a situation where we can't just add anything, because we are always afraid that we break something else. And that's why we have invented modularity and all that stuff. But we still have the problem, especially in the end-to-end tests, because there is this database thing going on. And what we could do is, of course, we can check how testing is done in other areas. Maybe they also have the same problem. So, I mean, in particular, the non-end-to-end tests, how they are doing it. Yeah, unfortunately, this does not help us, because the normal, so integration tests, component tests, unit tests, they all have a tooling which provide them ways how to easily mock databases. I mean, we know that Cypress also can mock end-to-end tests, but it is not so easy as it is in the non-end-to-end test. But yeah, the problem is still exists. So we are now in a situation where we know we need the database. We can't just throw it away or something like this. We depend on the database, and we know that we cannot achieve a situation like this where each test is isolated. So we need to find some strategies, some patterns where we can maybe mitigate the dependencies and so on. And this is something that I want to talk about in this talk, more or less. Yeah, so again, just compared, and this is also actually where the title comes from. So because if we are now comparing the non-database, so that the problem with the database that we have in non-end-to-end tests compared to the one that the end-to-end tests provide for us, it's really a difference in size. And honestly, I mean, I also writing end-to-end tests on my own, of course, quite often. I also work with Selenium. I don't miss that time, but this is also something that always interested me. Where are there any patterns that tell me how I'm going to navigate around this problem? Are there some workarounds and so on? And I thought that this is something that I missed. Then I thought, okay, maybe I'm just the only person that sees this problem. I don't find so many articles, talks or whatever. And then when I'm talked with my colleagues and so on, I saw, no, everybody's having the problem, but for some reason, everybody thinks he's the only person. And that's actually also where the metaphor, the elephant in the room, comes from. Namely, we have a problem and nobody is looking at it, or is just ignoring it. Let's put it like this. Good. So, yeah, what's the problem with the test-seeded database in general? Because this is something that we just do naturally. We have some kind of database that contains a structure or contains data, which is really designed for certain test cases. So our test starts and we have some edge cases in place. We can navigate there and so on. So everything is in order. Why not just keep it like this? Of course, there's always the question about reseeding the database, but the main theme really centers around that we have a specialized database that comes preceded and is really specialized for our tests. What's the problem there? Yeah, first of all, in the beginning, it is of course not a problem. So I have made the experience that you can come very far when you are working with a predefined testing database. That's not the problem. But the more tests you add, the more you run into these problems, because there is just one test seat, and this is a one-size-fits-all approach. So I'm trying to fit all my various test scenarios into a single database. And sometimes I have some edge cases where I can't say, okay, I just have to put them into the database and I can also put the other one. This will not work anymore. I mean, from a general, from a theoretical perspective, this is something I have already mentioned it before in the slides. We have tight coupling. So this is per definition something where we know already it will not scale. And then we have some other, maybe more practical problems. If it really comes to big, large enterprise systems, of course, end-to-end tests also need to be done there, then maybe the reseeding is not that easy as we might think of. Yeah, it maybe does not take 2 seconds and the database is up again. Maybe it takes an hour, or maybe it is not even possible to reseed in an let's say every day or something like this. This can happen. Maybe you just don't have one database, but you have multiple databases. It can be even worse. It can be the case that there is no database at all, or that some parts are not, or there are some parts which aren't served by a database at all, but that you have some kind of an external system. So your backend or your backend is again not calling in a database, but it is calling some service somewhere else. This can always happen. In that case, you don't have any access to any database, so you don't have any chance to seed anything. Yeah, so what are we going to do about this problem? We have to take a look at our application. There are maybe some potentials where we can step in and maybe, as I said, mitigate these problems. I mean, we can't fully eliminate them. We can just try to mitigate them. And if you are in a scenario, so if your application is an application that has the characteristic that many processes built around a certain entity, a certain record. So when you say everybody, so each request needs to send, needs to have some kind of an attached ID. So here are the examples with a user or a product or something similar. We often find this in multi-tenant systems when we say each. So we are some kind of website which is providing an organization, which is providing an administration for sport clubs or something like this. Then each sport club needs to log in, and then we are in the individual context. And we know all the things that this sports club can do only affects the sports club, the specific sports club, but not the rest. So if we are talking about this scenario, I'm calling here it individual context. You also have your insurances, banks. So this is always centered around a various customer. We can make our lives a little bit easier. Because what we have then, I mean, we have here this the database again with a users table, and you see here on the bottom a table diary and also a table booking. And each of these tables are linked to a certain user ID. So we could have a test or maybe, where we say there is a diary functionality. So I have a certain user and the user can log in. And after that, the user has a diary where the user can enter some data. Let's say we have a first test that wants to check the add diary function. In this case, before the test starts, so the arrange part or the given part, however you want to call it, is creating a new user just for these tests. And then it does the diary thing. And whatever it does not matter for the upcoming test, because the upcoming test just creates another record, it creates another user on its own. And this test would be something where we say, yeah, it should start the tutorial if there are no diaries in there. So this a little bit is similar to the use case that I have been talking before, where I said, I remove everything and then an after test comes and expects that there is an entry. I don't have here this problem because I always start on a green field. So I always start from scratch. And this also means that I have actually achieved something which we can call a complete isolation. So I really have here test isolation and the tests that do not depend on each other. So really look out for these specific things. When you have this individual context in your application, you can always do this. The question is, of course, how we are going to do this. What is here the best approach? I have prepared an example. So this is here. I hope that you can see it. Yeah. This is here, this website that has this diary function. At the moment, you don't see it because I'm not signed in, but you have here some holidays, you have here a customers list. And if I say I want to sign in, then I go with Max and username test. And then I have here my diary. So this is what I want to test. I want to test the diary. And for each test, I would now create a new user. If I go back to my code, so we have here in integration, we have here this diary spec. Yeah, just maybe some words about this. You see, I'm using here, so this is here the test, which is which is doing the complete registration process. It is using already some parts. As you can see, I'm using here page object model, the page object model approach. I know that this is a little bit discussed. There are some opinions against this approach. It really doesn't matter if you use Cypress commands, it's the same principle. So it does not change anything. But the thing that we have here, so user registration is quite a common thing. Unfortunately, it can happen that for setting up a new user, there is quite a very long process that we have to take. So if we take a look here at the sign up process, we see here that we have multiple forms. So each form must be filled in. Then we have some kind of activation. In this case, the activation comes just afterwards, where I have to type in some passcode, and then I have to sign in. So these are all steps that I have to do to achieve this complete test isolation, where I just have one particular user. And if we take a look and check how it works here, I just click on only. So if I run this test, we see how near the sign in process, the sign up process, sorry. Oh, quite a lot of work goes on. So now we are signed in, we have a new user, we click on diary and then we are done. This whole process takes 13 seconds. If you just now consider that you have multiple, let's say 50 tests that are doing this registration of the user in each test setup, this is something that you can't do. This is just too long. You can't just spend 13 seconds just for setting up a user. No way, you can't do it like this. And the solution here is quite simple, because we just need to ask ourselves, what do we want to test here? Do we really want to test or go over all the registration forms, or isn't it just enough if we can shorten this? Because we will have, of course, some tests that will test the sign-up process, but these are other tests. This test is about the diary, so we don't have to go over the complete sign-up process all the time. So we should not misunderstand or see the test, the actual test is equal to the test setup. There are differences, and this allows us to do things a little bit different. And what I mean by that is, of course, that we are using that we are calling the backend API directly. We do not click as the user does. We are just calling the endpoints and are creating the user on our own. Of course, if we are done with the user creation and we come to the actual test, then we do the visual testing. But just for the arranging part, we don't need any visual things at all. So what we can do is that we can do the site request command. Most of the time, this should not be a problem because our application, the front-end application, as you have seen, you have a sign-up process. There is some endpoint that this front-end application will be calling, and we can just reuse the same endpoint. There's not a problem, but we don't have to go over all the various forms. So this is what the second version of this test does. So we just say we should verify sign in via API calls. This is very short. So what I have here is that I have here an API object. This is again some kind of a page object model. And it is calling the sign up endpoint directly. It just sends the data that we have set up here from the fixtures and so on. And what we always have with these kind of request things, you will not have just one endpoint. Maybe you have multiple ones. So in our process here, we have 3 endpoints that we need to call. We need to call the sign up endpoint, then we need to call the activation endpoint because we need to activate the user, and then we can call the sign in method, which is the actual login. The problem is that we always have to be aware that we might require some data from the former requests. In this case, I need the user ID from the sign-up process because I need to pass the user ID for the activation. So please always keep in mind that you're using the then, because then you can continue with the data that you are getting back. Maybe if you're interested in seeing the code, I will of course also publish the GitHub repository after this meetup, but here you see how such an API class could look like. So we have here for each endpoint, we have a method. It has the arguments that the endpoint just requires, and it is using internally a post method. And what is behind the post method? It's just a site request command. Again, we are calling the base URL and all that stuff, and then it just works. So this is how this approach works. And if we take a look at the speed, so if you remember before we had 13 seconds, if I activate that one now, then we see here 3 requests. It's done within 1 second. So this is something which is already quite acceptable, that we say, okay, we require 1 second to set up a new user, and then we can just do whatever we want in complete isolation. But please be aware, use the site request all the time. Then it can be even better. We can even simplify this process even more. We could, for example, have an own test APIs. So it can be the case that our backend developers are providing us with certain APIs that are only enabled in the testing environment. And they could, for example, group all the commands into a single one and do it just, so we just need to call one method only, and it does and it does actually doing it internally. There might be actually some situations where you really require test API, so that you really require help from your backend team. If you think of a user registration, in my case, or in this case here, you see that after the sign up process, I'm activating the account by using a code. Usually what you can also have is that the backend is sending an email address which contains an activation link. You don't have a chance to get to this activation link because you would have to write a test that is connecting to some kind of an SMTP server and so on. But what you could have is, first of all, you could have in your backend that they say, okay, this is a testing system, so the token for the activation is fixed. It's always the same token in the backend. This is something, if this is not possible, then maybe you have a special endpoint that returns you the activation key for a particular user. So this is also something that is possible. If you run out of options and nothing of this is possible, then please, this is something that you need to discuss with your endpoint team, where you say, okay, look, I need some kind of way where you can create a new user for me. And by the way, if you create it, it would be good if you already also sign me in, so that I don't have to do the sign in process as well. This is done here. So when we take a look at the other one, at the third test, that is called, it should use the test API. You see here that we have a certain and a different object. It's called test API. And this one has the method sign in and create user. So it would be the other way around. First, it creates the user, but then it already signs us in. So if I call that one, then we see here that it more or less works also very quickly. Again, the same time as before, but in big systems where you maybe have quite multiple things going on in the registration process, so where it's really complex, it can happen that the setting up or just that the calling of the default APIs just takes too long, and you still require a test API to shorten the cycle even more. Because what we always have to do, we have to make sure that the test also run of course quickly. That's of course also very important. But this is a way how we can do this. Good. So again, this was now all about the individual context. So this was only when we say, yes, there is a user and it is enough if I create a new user, I have complete isolation. It will not work all the time. You will maybe have global context. This is something that we have here in our application. Here, when I, for example, when I say I click on the customers list, or maybe not on that one, click on the holidays list. So if I'm doing here some changes, this change will affect everybody because this is a global context. So this is a little bit more tricky. Because now we have the situation that tests will affect each other eventually. So the ordering is a little of the ordering of the tests is is very important, and we also have the problem that when the order is important, we can't parallelize the tests anymore. And as the last point says it here, it is unfortunately not very easy to solve, but there are some patterns, again, to mitigate this problem. The first one is that we try to identify so-called independent tests. Maybe the name is not quite fitting, but what these tests do is that they don't change anything. You can also say they are just smoke tests. They just open the website, they click on some things, and they say, okay, it should be there, it should be there, it should be there. Of course, if these tests don't change anything, then there is no test coupling, because everything is just based on the test seeding. The important thing here is you need to run these tests first, and it is fine if they are if they depend on the test database seed. So this is something that is accepted, but you need to run them first because that other tests don't accidentally change something, then they will not be working. What is also important is that you really need to look out for these kind of tests. There are sometimes end-to-end tests that have, let's say, 80% is just read-only stuff. They don't change anything, and then they have a small change, which is already enough. We cannot classify them as independent tests. If you have such tests, please remove this changing part, move it to another end-to-end test, and leave this test as independent test. You can come very far with these kind of tests. I have here the such an independent test with the customers spec, for example. No, that's not the one. The click-through test. So this is a test where we just verify if the application contains the holidays part, if there is Angkor in China, if this is showing, if we can open customers, if there is this customer from Italy shown, and of course we also check if the homepage is coming. So a classic smoke test, but we need to make sure they run before the test database starts to change. So again, if I go to Cypress and I click on click through, then you should not be a surprise. You're all Cypress developers, so I don't need to tell you how this test works. But you see here, these are just tests that don't change anything. They just make sure that the application is running. A small note from my side. What we are doing here is that we are asserting against texts. Maybe this is something that you don't want to do. Again, this largely depends on the type of your application. If you have an application which is a multilingual, multi-local website, it can happen that the texts change quite often. Then you maybe don't want to assert against the text. Otherwise, if you're sure my texts are stable, they will not change within a year or something, then it's fine. But also please be aware of asserting against texts. Good. So these are the tests that don't change anything. Then we have another pattern that we can use here. They are called the intelligent tests. So they are just not dummy tests that open our website, change something, and then leave. They know, they are aware that the application can look a little bit different, and they will, as the sentence says it here, they will say, I will create, for example, a customer in our customer list, and they will know how to find that customer. What do I mean by that? If I have a test before, which is removing all my customers, then I have an empty list. This test knows I need to click on add customer, then there is one customer, I click on it, and then I'm done. If I had a test before, which has created 100 customers, just to verify if the pagination feature of the table works, then this test is also aware of that. It knows that there is a table with pagination, and it clicks through until it finds the customer that it has been created, that has been created by the test. So this is something where we say, yes, it will work against everything that might be done before, because it really works with a little bit of an intelligence. The problem or the advantage is, of course, it's flexible. We don't really, I mean, we do have a test dependency, but this test is safe enough to protect against any changes or against anything. It will always work. The problem, of course, is, as the name says, intelligent requires a little bit more thinking. So we need to write a little bit more code. And the problem, of course, is that this code might be too much, that we say, no, it does not stand for it. I can't write an intelligent test for this. The example of an intelligent test can be found here in the, no, not here. Is it there? Oh, yes, it can be found here. We are creating here a new customer. And as I said before, it is not important for this test if the customer shows up on the first page or on the 50th page. It knows that there is a navigation in place, and it will do the navigation. And the logic, the intelligent part, is done here at navigate to end. So again, this is a page object model, but if I'm opening it here, you can see that this is some kind of a loop. So we are really clicking on the next button until we really find the last page, and then we say, and the last entry must be the customer. Yeah, I mean, you know, Cypress is asynchronous, so all the commands are running in asynchronous, and you should not try to write a loop with a while command, because then you have synchronity and so on. So this is why this might look a little bit strange. But if we let it run, so I see here, this is the customer spec. We see here customers, new customers created. It was a little bit quick, but you saw here that these tests went into a loop and really clicked as long until it achieved the last page. And then there was an assertion saying the last name of this grid must always be the user that I've just created. Something that you should do here as well is, of course, you want to remove this test user afterwards. So you leave the system as you saw it in the beginning, and this means that your intelligent test will also not affect others. So we still don't have the problem with the database seed because it still works. We don't need to reseed the database. We don't need to do anything because the tests, they don't touch each other. The problem is, if you can't do intelligent tests, if you can't do independent tests, if you don't have an individual context, then you have to live with it. Unfortunately, there are no other solutions, but the big hope is, of course, that a majority of your tests can be migrated to one of these three variations. And then, of course, you have to decide what you want to do. You can say, okay, I have some kind of dependent test groups. So you take some tests that really change the database into a logical group where say, yes, there is an implicit knowledge between these tests. So I have an add test. The test afterwards knows that a customer has been added. Then I have a delete test. The test after the delete test knows that this customer has been deleted and so on. You pack them all into one group and you let them run as group. Of course, the order here is important. And then, of course, you have to find ways how to reset the system. But this means, again, you don't need to reset the system after each test because there is some kind of tight coupling, but it's not that large. So you run 5 tests instead of 1 test, and then you reset the database. So this is, again, some kind of a mitigation strategy that might be a benefit. But to be honest, this is, of course, the worst scenario. So it does not get any worse in this case. And then we have the fourth, the obvious strategy, of course. You can always mock things. So you can always say, okay, I don't want to run against the real database. I just mock my backend. So there are no changes. It really runs independent. This is, of course, always something that you can do. There are 2 disadvantages to this approach. One is obvious, the other maybe not so obvious. The obvious one is, of course, that mocking requires some code. So you maybe have to also implement some kind of business logic into the mocking process. This is, of course, not something that you would want to, but if you don't have any chance and there is nothing else, you're not left with any other option, then that's just the best that you can do. And the other drawback is if you're in a big company or in a big organization, then you have a big advantage if you can say, I'm also testing the backend, because this is something that you do. You don't just test the front end, but you're also testing the backend. So you remove some of the workload of the backend team because you're doing also some parts of the tests for them. If you're mocking, then the backend test again needs to write the tests on their own. So if you are in a context or in a situation where budget is a little bit, so there's also some fights and so on about resources, let's put it like this, you're always in a better position if you say, yeah, I'm not just testing the front end, I'm also testing the back end, I'm also testing the database, I need all the money to write the tests. Of course, if you just test the front end, your negotiation position might not be as that good. This is not a technical thing, but something that you maybe also should be aware of. Good. Summary. Again, we have here the two approaches, or maybe the two dimensions. Maybe that's the better word. So the lower it is, the more your tendency to cry, and the more on the top it is, in a better position you are. Test on, or if you rely only the test seeded database, yes, it works, but again, I think I hope that it was clear that this is not a strategy for a long-term strategy. So you will run into a position where you say you cannot add any more tests because everything is coupled. You have tight coupling there. It will not work anymore. You should use the application API. Just create the things that the test requires by using the test API. I don't depend on the database seed. The best situation is, of course, if you have a dedicated test API. This makes things just better. That's just the case, as we have discussed in the user part. And on the right side, we have the various context and patterns for writing the test themselves. Again, if you're in an individual context, so this means that all your tests are dedicated to one single entity and you always need to pass the ID, then just create for each test a new entry and you're done. You have full isolation. Of course, if you have a test API and you can use it with the individual context, you're in a happy place, so to say. And then we have, of course, the global context where you have data that is not personalized. And then again, the independent test, which is a read-only test, it does not change anything. It can depend on the test seeded database. That's fine, but run them first and make sure they don't change anything. Then we have the intelligent tests. They require more code, but they are flexible. They can really adapt to the application. Then we have our dependent test groups where we link tests together to form groups. Then maybe afterwards we need to reseed the database. And if nothing works, or if you say, I don't want to write dependent test groups at all, because I just simply cannot reseed the database, then you can use the mocking functionality, which of course also gives you a full isolation of the tests. So this is the big picture with all the various options that you have. And the final slide, you will not have completely isolated tests. So I never saw a project that managed that all tests are completely isolated. This will never happen, but that's just the nature how end-to-end test works. This is just the way it is. If we can't achieve it, then we should at least try to mitigate or to minimize it and come up with loose coupling. This is here a typo. It should actually say minimize tight coupling, and you should achieve loose coupling. Yeah, please always try to prefer the backend calls and don't try to work on a perfect test seed. And yeah, always look out for opportunities with individual context. This is the best option that you can have. Maybe it appears after a second look. From my experience, there are quite some options. So there are many possibilities in an application you might not be aware of. So just look out for that, and then it should be better. Let's put it like this. Okay. That was it from my side. Thank you all for attending, of course, and I would be happy if we can have a discussion and that you also share your experiences that you have with the databases and patterns, of course.